Determine if the series converges or diverges. If it converges, determine its limit. So here we got first series here, and this is an, and here is an. We know that for a series to converge, n from any number to infinity, the necessary condition is limit of an when n goes to infinity should be 0. This is not enough to show this converges, but this is necessary. In other words, if in this series, if this limit is not equal to 0, then the series diverges. Okay. Here, if we look at closely, when n goes to infinity, 5 over infinity, that's 0. 1 over 5 raised to infinity, that's 0. But that does not tell anything. If this limit is not equal to 0, then this series diverges. But limit of an equals 0 does not tell anything. Here, natural log of something, let me do number a and find this limit. Limit of this n squared plus 5 over 3n squared plus 1. When we want to find this limit, natural log of something, we can take this limit inside. So natural log of limit n going to infinity of n squared plus 5 over 3n squared plus 1. And when n goes to infinity, plus 5 plus 1 does not count, just n squared over 3n squared, and that's 1 over 3, because we got the same power on the top and bottom, just 1 over 3. So this is natural log of 1 over 3, which is not equal to 0. Okay, this is some decimal number. That means this series diverges. Okay, the series diverges, and this test is test for divergence. When we take limit of an, and if it's not 0, the series diverges. The n term test, or the test for divergence. Test for divergence. Okay, now here if we take the limit, it's going to be 0, but that does not conclude anything. Okay, now if we look at closely, this is kind of sum of first plus sum of second. So pretty much we have two series here, and we know that series 1 over n from any number to infinity, this is harmonic series, and this series diverges. Okay, this is the most famous series. This is diverges. If we have any number, we can simply pull outside, and we have that situation 5 over n. So here if we just look at 5 over n from a finite number, any number, positive number to infinity, that is, in fact, we can pull 5 outside, 1 over n from 1 through infinity. And if we look at it closely, now this is harmonic series, and look at here, this diverges. Okay, so this diverges. For this series to converge, both series is a sum of two things, should diverge, but one of them diverges. So this one, just the sum of 5 over n, this is diverges. Okay, my bad. Diverges being 5 times divergent series, because this sum will be very, very big, infinity. So 5 times infinity is infinity, being constant multiple of harmonic series. Okay, diverges being 5 times, or we can just shift being harmonic series. This part, the whole series diverges. The given series means we got sum of two different things. This given series diverges.